Okay, dear students, over the past many lessons on electricity, these are the 10 formulas that we have looked at for electricity. Okay, let's go through them very quickly as a form of revision for the electricity chapters. Okay, first up, we have I equals to Q over T. Okay, this talks about the energy in relation to charge and time. V equals to W over Q. Okay, this talks about the potential difference in relation to work done and charge. But in this case, V here we are just writing it in a general form. There's also EMF, which holds the same formula, but just the V, we are denoting it as a different thing. Okay, and there's also the most commonly used formula, V equals to IR. In this case, potential difference is equals to current multiplied by the resistance. Okay, this is also followed by the something on the series circuit and the parallel circuit. Okay, each of them have a special condition. Okay, so please go and read up on it before you just take this formula. Okay, for series circuit, okay, one special thing that we need to remember is V equals to V1 plus V2 and so forth. While the total resistance will be R1 plus R2 and so forth. Okay, next we have the parallel circuit. Okay, for a parallel circuit, this number 6 here is talking about the Kirchhoff's law. Total current is equals to I1 plus I2 and so forth. And the resistance, okay, in order to calculate the total resistance is 1 over R equals to 1 over R1 plus 1 over R2 and so forth. Okay, next up we actually reached the part on the practical electricity itself, where it revolves heavily around energy, electrical energy. Okay, so in those chapters, okay, we are revolving around these few ideas, but also using the formula V equals to IR also. Okay, so first we have energy equals to power times time. Okay, and from this formula, okay, earlier in the chapter, in that same chapter, we will talk about energy in terms of joules. Where energy is in terms of joules, power must be in terms of watts, time must be in terms of seconds. In the later half of that same chapter, we talk about energy in the form of kilowatt hours. So power is in terms of kilowatt, time is in terms of hours. Later on, we talk about power is given by the formula V times I, potential difference times the current. Okay. After that, we also talk about energy in terms of VIT. But if you look at energy equals to VIT, this formula, if I break it down again, when energy is in terms of joules, VI, this portion, actually if you look at formula number 9, it's actually power. And T is just time. So it's actually a substitution of formula number 9 into formula number 8. So I won't say that this is a new formula. Instead, this is just an expansion of, a substitution of a formula into another one. Okay, in that same chapter, we also talk about power in another two forms. Okay, power equals to I squared R and power equals to V squared over R. How do you actually get these two forms? It's a substitution of V equals to IR, okay, in the various forms into power equals to VI. And last but not least, before we touch on this practical electricity chapter, the last formula that we talk about is the resistance formula. Okay, the resistance is rho L over A. So in that particular portion, we are saying that resistance is directly proportional to the length of the material. Resistance is inversely proportional to the cross-sectional area of the material, and resistance is affected by the resistivity of the material itself. Hence, this formula R equals to rho L over A. Okay, if you're unfamiliar with any of these parts, please go and read through your notes or the textbooks again for the formula itself and explanations, okay, on top of the uses, okay, and the examples.